start with partial differentiation. So before moving on to this partial differentiation, we have to know what is a function which is defined on 2 or 3 variables. So you must until now have known what is a function in one variable. So what is a function in one variable? So can anybody tell me what is a function in one variable? What is its definition? So suppose you have some set over here, right?
1x or y, like.
Yeah. So you have f of x is equal to say x square, that is your function. Why? Because every element from this domain is mapped to some unique element in this set by this function f. So that is the function in one variable, because here all the they are all the numbers, they represent only one dimension. So, but in most of the real life phenomena, any phenomena is dependent on more than one variable. So in that case, we can say for this function f, we input several variables instead of just one. For an example of this thing, you could see, suppose you have some tree, right? So you have some tree over here. So what we are doing, we are looking for its growth. The function f that defines the growth of this particular tree. So for the growth of this particular tree, what are the factors that would affect its growth? Firstly, you have to identify those. So what would be those? Firstly, it would depend upon what amount of water is being supplied to it. That could be one variable. Another variable is that what are the number of parasites or insects that are around this, so that they are damaging this, right? So this is one thing. Another thing is that how much fertilizer or pesticide has been involved in to grow this particular plant, or we say what are the weather conditions they are involved for this for the growth of this particular plant. How is the soil of that particular area? So these are some of the factors that could be taken into account in order to study what is the growth for this particular uh, tree, right? So here, first thing that we should know that we have two terms. One is the independent variables. Another thing is that of dependent variables. So what is an independent variable? Which is not depending on others. So in this case, all these 5 things, they are independent of each other, because weather does not affect soil as such, and it does not affect how much amount of fertilizer has been used in the for the present tree. So all they are the independent variables. So these are all the independent variables, whereas dependent variable is the one which is the growth, which is depending upon all the other independent variables, right? So that is the dependent variable. So firstly, you should note this thing. In mathematics, we generally denote the dependent variable by y. That is one thing, and usually some x by the independent variable which you had been studying until now. But it could vary also. It could depend upon the context in which you are talking. Suppose previously you were taking into account this first derivative of y with respect to x. So here we call y as the dependent variable, whereas this x used to be the independent variable. This was the case which we were previously studying, right? So here the situation is quite different. So here what do we say? We say that suppose x is equal to r cos theta and y is equal to r sin theta. So in that particular case, if I wanted to calculate, firstly you have to identify what are my independent variables here and what are my dependent variables here. So independent variable in this case would be r and theta, because they could choose any value here. They are r as well as theta, and the dependent variables are x and y. Why? Because x and y are depending upon the values of r and theta. So their values would change whenever you change this r and theta. Whenever you change this r and theta, this x is also, x and y, they both gonna change. So these are the dependent variables, these are the independent variables. So accordingly, you should first know how can you identify these dependent and independent variables. So it would be meaningful in this case that you calculate the derivative of the dependent variable. You calculate the derivative of the dependent variable with respect to the independent variable. So before moving on to this, studying this partial derivatives, what we'll first do, we'll see how can we define the limits in case of these several variables or 2 to 3 variables, and how can we define the continuity in this particular case. So that is what our first aim is. So for that, suppose, let me first give you some examples. Say you have first example, the function is defined to be w, that is equal to square root of y minus x square. So here this is one function. Here w is your dependent variable and x and y, they are independent variable. Why? Because x and y can assume any value, they can take any value, and w will depend upon the values taken by x and y. So that is dependent and these are independent. So w would be a single number, and whatever input you are giving to that function, so that is nothing but x comma y. So basically, suppose you have some machine of this kind, this is your function. So what you are doing, you are feeding an input to this as x comma y, and the output that is obtained, this is your input that you are giving to your function. So the output that is obtained as a function is some single number, and what is that single number? That single number is w, right? So this is what is happening here. So now our function is omega is equal to square root of x minus y square. So now you have to see what is the domain for this particular function. So what is the domain for this particular function? That means the meaning for domain is that what values of x and y you could provide as an input to this particular function. So obviously you cannot provide all the values here, because we say this function w, that is defined from the set of real numbers to the set of real numbers, because here we are not talking about complex numbers, right? So it is meaningless to say that the square root of some quantity, this should be some positive number, because we are in calculus, we only deal about this real numbers. So we say y minus x square, this quantity should be positive. Why? Because we do not want some square root of some negative number. Why? Because this becomes the complex number, and this thing is not required here. So that means we will make sure that this y minus x square, that is a positive quantity. How will this become a positive quantity? Whenever your y is greater than equal to x square. So this becomes the domain. This becomes your domain. So you will only choose those x comma y such that this condition is satisfied. Your y should be greater than equal to x square. So suppose you take x as 2, so x square would be 4 in this case. So you could choose y greater than equal to 4. So you could choose this to be 7 or whatever number you would like. So this is one appropriate number which could be fed into this particular function. So now we will talk about its range. What would be the range? Range is that particular number which are obtained after substituting this domain into the function. So what would be the range for this function? So now you see, you'll only input positive numbers into this. So for positive numbers, from where to where they will vary? They will vary from 0 to infinity only. So this is what we are saying. So this is the range for this particular digit. Why? When will you obtain 0? Whenever your x comma y tuple, that is 0 comma 0. So this is one example. Similarly, we have another example also. So let's see example second. It says that suppose your function f of x y, that is say defined by w, that is nothing but x y divided by x square minus y square. So this is the function that is defined. Now you have to suggest what is the domain of this particular function and what is the range of this particular function. So here your domain could be any number such that the function does not become infinity. So that means for what values your function will be infinity? Whenever your denominator is equal to 0. So what is your denominator? Denominator is x square minus y square is equal to 0. There your function becomes infinity. And what are these values? These values are x is equal to plus minus y. So that means for the domain, you could have all the numbers except this x not equal to y and x not equal to, x should not be equal to y and x should not be equal to minus y. So this is your domain. And what would be the range? For range, we could have all real numbers. So whenever you input all the real numbers here except these numbers, you would have all the real numbers here. So our interval of range would be minus infinity to plus infinity, right? And now suppose we have another example. Suppose the given function here is f of x, y, z. So now we are having 3 independent variables. So that means our function is of 3 variables, right? So it is defined like this: square root of x square plus y square plus z square. So when you calculate this, that would be only a single number, right? So now we have to look for its domain as well as its range. So what would be the domain for this particular function? That now you could input any kind of number into this, there would be no problem, but this quantity should be positive. So now for which values of x, for which values of y and for which values of z, this quantity would be positive. It would be positive for all values of x, for all values of y, for all values of z. Why? Because we are squaring the term. So square of any quantity is always positive, their sum is always positive. So square root would always be that of positive number. So domain here would be whole real line. So here it would not be whole real line because you have 3 dimensions. So it would be the whole 3-dimensional plane. And what is the range for this particular quantity? For range, we would be getting one single number. So its range would be from minus infinity to infinity. So that is the concept of functions of several variables. So next, let me define what is the limit of such functions. Now to study limits, we'll consider the limits of one-dimensional functions or functions with one variable as the base. So now if you remember, you were given some point. Suppose this is your y-axis, this is your x-axis, and on x-axis, suppose you are given this point x naught. So you say whenever your x reaches to x naught from the negative side, so whenever your x reaches to this x naught from negative side, f of x, this was your left hand limit. Left hand limit whenever you had this function of one dimension, right? So you had this left hand limit defined like this. So that means whenever the distance between this point x and x naught is really less, in that case the value of function reaches some limit, say L negative, right? And then you'll seek the limit of this function from the right hand side. So that means limit x goes to x naught positive f of x, that is L positive. So this is the right hand limit defined for the particular function. So now you say the limit of these two functions exist if the left hand limit is equal to right hand limit. So this is the definition. So the limit exists whenever the left hand limit is equivalent to right hand limit. Why in this case we only take the left hand limit and the right hand limit? Because we only have this one dimension with us, the only x-axis. This y-axis that represents the value of the function, and it is not the independent variable that we are talking about here. So we can only move like this. We can either go to the right or to the left. So only two directions are taken in this particular case. So now you consider the case of several variables, functions of several variables. So in this case, what would be the limit? So now we are saying we have some function f of, say, x comma y. That means I am talking about the function of two variables now. So how would this be defined? We have two as the independent variable x and y. So say this is your x-axis, this is your y-axis. These are two the independent axes, and your function say is defined by w, right? So let me define this w here. So you could input whole of this xy plane into your function. So that is one thing, and whatever result you will get it somewhere corresponding to this w axis, right? So this is the thing. Now in this case you have some point here as x naught comma y naught. So in how many ways? So the question here is, in how many ways can you move closer to the point x naught comma y naught? So how many directions are possible to get close to this point x naught comma y naught?
मैम
हाँ जी,
मैम कर्सर तो कुछ दिख ही नहीं रहा है, जो भी आप राइट कर रहे हो कुछ नहीं दिख.
so we'll say the point x comma y would tend towards this point x naught comma y naught in how many ways? From how many directions can you reach this point x naught comma y naught? So here you can see, because we have this whole plane as the domain, so we can reach this point in an infinite number of ways. Either you come from this left hand side or from the right hand side, or you come from top, or you come from bottom, or you come from this side or from this side. So there are infinite number of ways to reach this particular point. So we say here the limit is path dependent. So that means it cannot simply be defined by saying that the left hand limit is equivalent to right hand limit, because here we cannot conclude that limit exists whenever left hand limit is equal to the right hand limit, right? Why? We cannot conclude from here that limit exists whenever left hand limit is equal to right hand limit. Why? Because there are infinitely many ways to reach the point x naught comma y naught. So this is the thing. So how can then we say the limit of this function exists? So by definition, the definition in this case of limit, it says that, so we say the value of the function w is equal to f of x comma y can be made as close as we like to some fixed number capital L by taking the point x comma y, which is some arbitrary point, close to the point x naught comma y naught, but not equal to that particular point. So in this case we write the limit x comma y tending to x naught comma y naught f of x, that is equal to some number L here. So graphically we say, suppose this is your y-axis, this is x-axis, and this is the x-axis representing a function's value, right? So this is x-axis, y-axis, and this is the f of x comma y. So in this case we say we have some point here, this is say x naught, this is y naught, so some point here would be this x naught comma y naught, right? So corresponding to this point, suppose we are here, not here, suppose we are here. So whenever you make this distance very small to each other, the value of the function defined at the point f of x comma y should be very close to the value L here. If this is the case, so these values should also be very close. If this is the case, we say the limit of the function exists. And how do you measure this distance in two dimension? The distance between 2 points, one point is this x comma y, another point is this x naught comma y naught. So the distance defined between these 2 points is calculated using the formula square root of x minus x naught square plus y minus y naught square. So this is the distance corresponding to 2 points present in 2 dimensions. So let us now see certain examples. So suppose I have this function limit x comma y going to 1 comma 1. So the function is defined like this: x minus xy plus 4 divided by x square y plus 5xy minus y raised to power 4. So here they are asking calculate its limit. So you could calculate the limit by directly substituting the values of x comma y. So the value of x is 1, the value of y is also 1, right? So you could directly substitute it here. Why? Because the denominator does not become 0. So it would be 1 minus 1 into 1 plus 4 divided by 1 square into 1 plus 5 into 1 into 1 minus 1 raised to power 4. So that would be 1 minus 1 plus 4 divided by 1 plus 5 minus 1. So this minus 1 and minus 1 cancel, so you will be left with the answer 4 upon 5. So now you see another example. Another example says calculate the limit x comma y tending to the point 0 comma 0 at this point 0 comma 0 of the function x square minus xy divided by square root of x minus square root of y. So how do you calculate this limit? When you directly substitute the value, let's see. If you substitute the value directly, we would have 0 square minus 0 into 0 divided by square root of 0 minus square root of 0. So in this denominator, you would end up with 0. So that means you have some quantity here, some number here divided by 0. So that means your function becomes undefined whenever you directly substitute this limit over here. So what you do instead is you try to rationalize this function. So what we'll do, we'll multiply by this term. We'll multiply by, the function would remain as such, and then we'll multiply by square root of x plus square root of y, and in the numerator also we'll multiply by the same term, so it won't make any difference. So we can multiply this thing. So from here, what will you get? In the denominator you would have square root x whole square minus square root y whole square, and in the numerator what will you have? When you solve this thing, it would become, you could take x common, so it would be x minus y and then square root of x plus square root of y. So here you would have x minus y into square root of x plus square root of y and divided by x minus y. And here the limit also varies from the point x y to 0 0, and here also the limit varies from the point x comma y to the point 0 comma 0. Here also the limit varies from the point x comma y to the point 0 comma 0. So this quantity now cancels with this one because this was creating the problem. So now you were only left with limit x comma y tending to 0 comma 0 x into square root of x plus square root of y. So now you could directly substitute the limits. It would be 0 into square root of 0 plus square root of 0, so it would be 0. So this would be the answer. And we have also several properties of limits. What are these? The properties. If suppose the limit of certain function taken at this point 0 comma 0, or we say at some general point x naught comma y naught of the function f of x comma y, suppose this is L, and the limit of the point x comma y tending to the point 0 comma 0 at this function of this function g of xy, that is m, then we have certain properties. First property is that the sum rule, which states that the limit of x comma y tending to the point x naught comma y naught, here also we have x naught comma y naught, so of the function f of xy plus g of xy. So what would be this? This would be L plus M. Then we have the difference property. It would say that limit x comma y tending to x naught comma y naught, so that would be f of x comma y minus g of x comma y, so it would be L minus M. Then we have this product property. So limit xy going to the point x naught comma y naught of the quantity f of xy multiplied by g of xy, so it would be equal to L multiplied by M. And then we have the quotient rule. We have this quotient rule saying limit xy going to the point x naught comma y naught of the function f of xy divided by g of xy. This is nothing but L divided by M, provided this M should not be equal to 0. And then the fifth property is limit x comma y going to the point x naught comma y naught into k where k is some scalar. So k multiplied by this f of xy, so this is k multiplied the limit of this particular function. And then the last property here is that of power rule, that says that the limit x comma y tending to the point x naught comma y naught of the function f of xy whose power is m divided by n is the value of L calculated at m by n, where this is some real number. So these are certain properties of limits. So in the next class we will be studying about the continuity of functions of several variables. So I hope this is clear to you all.